All right, so there's number 7, and we're on page 329 again. You want to kind of check in your book where we're reviewing. Probably. The thing about number 7 is it's very similar to the problems that preceded it. I know some of you had questions on with 5 and 6. So let's see if we can get to the root of this concept called direct variation. Remember, that's a subgroup of linear. Linear means constant slope. Direct variation means a constant slope passing through the origin or 0, 0. It's a case where whenever I take, so to be a direct variation means that dividing y over x gives me a constant value. That's the key formula. That's what we emphasized in class. You wrote it down. Theoretically, you memorized it, and you tied it to this term, direct variation. So that means that if y is -3, when x is 1, okay, well, let's see, that's -3 over 1 equals k, or k is just -3. That's the constant of variation. That's the number that ties it all together. If we look back in the book at numbers 5 and 6, it says, tell whether each relationship is direct variation. So what you do in those cases is you keep comparing y over x, you divide it out, and you see if you keep getting the same number over and over again. If you do, it is direct variation. If you don't, it's not. Because that's the fundamental principle. Now, once I know the variation constant, we have this equation. It's just like this one. We made a little twist. So for this relationship, y would be -3x. So if x is -6, y would be a +18. And I can keep reusing this formula to create a whole table of values if I want to, because I know what the variation constant is between these 2 points. I also know what the slope is going to be for this relationship. So I can keep generating data, I can keep extrapolating, I can keep making predictions, because that's what this is really about, is writing an equation that models that situation. What more can I say about 7 and 8? The big idea really has to do with remembering this rule of dividing y over x to get that constant, and then using that constant to write an equation that I can keep solving. And this applies to 7, it applies to 8, and it also applies to 15 and 16. The 15 and 16 get a little trickier because I think they introduce some fractions into it. We can take a look at another problem.